This is Activity 1, Coordinate Pairs for Lesson 13, More Solutions to Linear Equations. And in this activity, you're given 3 equations, and you're asked to choose a value for x, and it's your choice, whatever you want to choose, and find the corresponding value for y. When you do that, you find a value for x and a value for y. If you put those 2 values back into the equation, it will make that equation true. So what we say is that it makes that equation true. So in fact, 6 times whatever value you choose for x, and then 7 times whatever value you get for y, they will be equal to each other. All right, so for 6x equals 7y, what I chose is 6x is 7 times y. So you look at this and just say it to yourself. 6x is equal to 7 times that value of y. So y will be 1/7 of 6x. So this 1y, so eventually you're going to have to divide whatever you choose over here. That's going to have to be divided by 7 because it's going to be 1/7 of 6x. So choose a multiple of 7 for x because 6x will be divided by 7. I don't know if that makes sense, but just go through it a couple times. I want to choose a value for x that makes it easy for me to divide this product 6 times whatever that value is by 7. I'm going to have to divide it by 7 to figure out what y equals. So if I choose x equals 7, so that's probably the easiest one. So 6 times 7 equals 7y. So now to figure out what y is, I have to divide 6 times 7, which is 42 by the way, by 7 because I have to get one of these y's. I have 7 of them, so I had to divide them by 7 to get down to 1y. So 7y equals 6 times 7. I just flip this over the equal sign, switch the order I'm writing it. So 1y equals 6. So if 7y's equals 7 6's, then 1y is going to equal 1 6, or y is equal to 6. So the coordinates for that point are 7, 6. So if you try another one, try 2 times 7. So x equals 14. So 6 times 14 equals 7 times y. So once again, you're going to have to divide 6 times 14 by 7 because you want to know what 1y equals, not 7y's. And so if I write this out as 6 times 2 times 7, when I divide by that 7 there, I'm left with 6 times 2, which is 12. So 7y equals 6 times 2 times 7. So I'm going to divide by the 7, so to get to 1y. So I'm going to divide 6 times 2 times 7 by 7. So that's going to give me 6 times 2, or y equals 12. Now this is a proportional relationship because you can get this to y equals kx, so some value times x. So if I double the x coordinate from 7 to 14, then the y coordinate is also going to double from 6 to 12 because it is a proportional relationship. So what that means, and we'll look at graphs of this equation in just a moment, but if I put these coordinates back into this equation up here, it will make it true. 6 times 7 does equal 7 times 6, or 6 times 14 does equal 7 times 12. So it makes this equation true. These coordinates make this equation true. All right, so let's try the next one. 5x plus 3y equals 9. And all I'm doing is trying to look at it and figure out what would be a good choice for x, given that I'm going to have to divide by 3 at some point. Because I have 3y, that means I'm going to have to divide by 3, or multiply by 1/3, they're the same thing, to figure out what 1y equals. So I'm going to choose a multiple of 3. Now 9 is already a multiple of 3, so you're going to have to do some subtracting, do a few other things, but because 9 is a multiple of 3, then and I'm going to divide by 3, I really have to worry about my value of x being a multiple of 3. A little bit hard to understand, but you work with it, you can begin to develop some understanding of what's going on. So as we work through it, maybe it will show up. So I'm going to choose x to make 5x a multiple of 3. So for x, to do that, you're going to choose a multiple of 3 for x. Sorry about that. So x I'm going to choose, and make it the very easiest one, I'm going to choose x equals to 3, or x equals 3. So 5 times 3 plus 3y equals 9. So now I'm going to have 3y is equal to 9 minus 5 times 3, which is 15. So if I'm adding 5 times 3, or 15, I have to subtract that away. So 9 minus 15, or written as 5 times 3. So now I have 3y equals 3 times 3, which is 9, minus 5 times 3, which is 15. So now I'm using the distributive property. And what I'm doing is factoring out this 3 because I know I have to divide by this 3 here. So I want to be able to divide by 3. So it's 3 times 3 minus 5. So if I have 3 3's, if I divide by 3, I'm going to have a single 3. And if I have 3 5's, if I divide by 3, I'm going to have a single 5. And so this is 3 minus 5. So now I can divide. If I have 3 y's are equal to 3 of these things right here, 3 minus 5, then 1 y is going to equal 1 of these. So it's 3 minus 5. 3 minus 5 is, I'm going to use the inverse operation of addition and the additive inverse of a positive 5, which is negative 5. So 3 plus a negative 5, add those together, y equals negative 2. So this point, 3, we chose x equals to 3. Y we figured out is equal to negative 2. If I take those two values and put them back into this equation, plug them into this equation, so then 5 times 3 plus 3 times a negative 2 will in fact equal 9. It makes this equation true. So these coordinates are a solution to this equation. It makes the equation true, and this equation defines a line. There's a if we graph this equation, we're going to get a line. We're going to do that in a few minutes. All right, one more. I know this is tough, and they don't mean it to be this tough, but just this simple direction leads to all these things that you can think about. So in this case, it's y plus 5 minus 1/3 x. Well, I know I'm going to have to multiply actually, you don't have to do, because y is by itself, you don't have to do any division to figure out, or multiplication for that matter, to figure out what y equals. It's just subtraction or addition. So I'm going to just choose a multiple of 3 because I'm going to multiply x by 1/3. So if I choose a multiple of 3, it makes it easier to deal with that calculation. So I'm going to choose x equals 6, which is 2 times 3. So now we have y plus 5 minus 1/3 times 6 equals 7. Well, 1/3 of 6, and this is why I'm choosing a multiple of 3, 6 divided by 3, or 1/3 of 6, is 2. So now we have y plus 5 minus 2 equals 7. And so 5 plus a negative 2, or 5 minus 2, is equal to 3. So now we have y plus 3 equals 7. If I add 3 to get y by itself, I have to subtract this 3. So then y is going to equal 7 minus 3, which is 4. So now we start out with x equals 6, we have y equals 4. So these coordinates, if you plug them back into this equation, will make this equation true, will be a solution to this equation. So these coordinates are a point on a line. So those coordinates get plugged back into this equation. This is an equation for that line. So in fact, 4 plus 5 minus 1/3 of 6 will equal 7. So you plug it back in, you do that calculation. This side will equal 7, which is what's on this side. And so let's look at this. So this equation defines a line. It's an equation for a line. If I want to draw that line, I'm going to rewrite this equation in the slope-intercept form, the form where you know what the slope is and you know what the y-intercept is. Well, the y-intercept in this case is 0 because this is a proportional relationship. And the slope is 6/7. So every 7 units along the x-axis, you're going to go up 6 units along the y-axis. So this is that line. So I'm going to go out 7 units along the x-axis and up 6 units along the y-axis, 7 units, 6 units. And 2 points on that line, we figured these points out by choosing x as 7. Oh, it's okay. By choosing x as 7, we calculated then that y is equal to 6. And choosing x as 14, we calculated y is equal to 12. Oh, this was, right, I knew I had to divide by 7, so I want to choose a multiple of 7. That was it. All right, so those 2 points, graph those 2 points, they are on this line, and so their coordinates make this equation true when you plug in the x coordinate and the y coordinate, because this equation is this line, and these 2 points are on that line. So they are solutions to this equation, which makes this equation true. Let's try that again. 5x plus 3y equals 9. I'm going to rewrite this in the slope-intercept form. So the slope is a negative 5/3, and the y-intercept is 3. So just go through some manipulations here. So 9 minus 5x, you have to divide it by 3 or multiply it by 1/3. The same 9 minus 5x. 1/3 of 9 is 3, minus 1/3 of 5x is 5/3 x. And to change this, there's lots of stuff to think about. Change this to addition, and you're going to subtract the additive inverse. So this is subtracting a positive 5/3 x. 5 times 1/3 is 5/3. So you're going to add a negative 5/3 x. So you get this equation. And so now I can draw this line. The slope is positive 3. The y-intercept is positive 3. The slope is negative 5/3. That means 3 units along the x-axis. 1, 2, 3. 5 units down along the y-axis. 1, 2, 3, 4, 5. 3 units along the x-axis because it's the change in y over the change in x, the number of units along the y-axis over the number of units along the x-axis. So the number of units along the x-axis, positive 3. Units along the y-axis are negative 5. So 1, 2, 3, negative 5. 1, 2, 3, 4, 5. Now you could say it's a negative 3, 1, 2, 3, positive 5. 1, 2, 3, 4, 5. That's still going to give you a negative 5/3, but we can look at it as a negative 5 and a positive, we can look at it as a positive 5 and a negative 3 if we want. Either way works. All right, so the point on that line we figured out was 3, negative 2. So we go over 3 is the x coordinate, negative 2 is the y coordinate. So this point is on this line. This line is defined by this equation, 5x plus 3y equals 9. So if you take these coordinates, x equals 3, y equals negative 2, and place them into this equation, it will make this equation true. It's a solution to this equation. So x equals 3, 5 times 3 is 15. Y is equal to negative 2, 3 times negative 2 is negative 6. 15 plus negative 6 does equal 9. So it makes this equation true, and we say that these coordinates are a solution to this equation. Okay, one more time. Y plus 5 minus 1/3 x equals 7. So move everything over to the right side. So now I have y equals. So I'm going to subtract 5 from 7. 7 minus 5 is this 2 right here. I'm going to add 1/3 x. That's this 1/3 x right here. So this tells you that the y-intercept is 2. It's going to be right here. And the slope is 1/3. So that means for every 3 units in the x direction, you're going to go up 1 unit in the y direction. So the slope is, the y-intercept is right here, is positive 2. So 3 units in the x direction, 1 unit in the y direction, 3, 1, 3, 1, 3, 1. So now a point on this line is what we figured out. It's 6, 4. So you go over 6 units and up 4 units. This point is on the line. So if you take the coordinates, the x-coordinate and the y-coordinate, you put them back in this equation, it makes this equation true. So 6, 4, the coordinates for this point, are a solution to this equation. This equation defines this line. 6, 4 is a point on that line, so its coordinates are a solution to this equation. A lot of words, a lot of things to just get comfortable with as you think through this. But keep practicing, try to do it, and you'll reach a level of understanding the more you practice.